Hey physics, this is Mr. Hausman. If you were absent or were not present for the lesson on calculating charges that are gained or lost, this is a video that will help you understand how to better understand that. So let's kind of frame what we're doing. We're talking about charges, and charges are measured in a unit called coulombs. And gaining or losing charges. Now, let's face it, when you have a metal conductor and it's sitting there isolated from like the table or a person's hand, and we do that by creating an insulating stand, right? That means make sure that any charges that are on this metal sphere, right, are going to stay there once they're put there. But we, of course, know that there are many ways to move them. For example, there's contact charging or there's induction charging. And so when we gain or lose charges on this metal sphere, it's always about gaining or losing electrons. Do the electrons leave or do the electrons get gained, or do we gain electrons? You can't do both, but we can kind of do problems with either one. Now, what do we also have to be aware of? We have to know that Q stands for charge. So we're going to be interested in knowing what's the starting charge or the initial, and what's the final charge. What's the charge after electrons have been gained or lost? So how do we go about tackling them? Well, there's two relationships that we're going to be using. This is the main one. This main one says that the Q after, that's Q final, equals the Q initial, whatever you start with. And what is this delta Q? This means the gain or the loss. So let's set this up. Okay, so Q final equals Q initial, gain or loss. Well, the formula here says it's a plus sign, but I teach it a little bit differently. I want you to read the problem and see whether it is a gain or loss problem. And if it's a gain, we're going to put in, of course, a plus sign. There's a gain of electrons. Now, how much do you gain or lose depends on two key variables. N. N, as you can see up at top, is the number of electrons, and literally, N stands for number. But then how much does each electron carry with it? And that's referred to as the elementary charge. It's not just -1 like it was in chemistry. Here is the elementary charge for an electron. So we're going to be needing to do kind of two steps. We're going to have to identify how much do we start with, and then how many particles we're gaining or losing, and then what's the charge of each. And then we'll use our calculator to do a calculation. Okay, so what's the starting charge if it is neutral? Well, neutral means 0. There's no charge. We could put in 0 coulombs. And we already know that it's gaining electrons, so let's put in a plus sign. And how many electrons is it gaining? Okay, it's gaining 2,000 of them. We can see that right here. And what's the charge of each electron? -1.6 times 10 to the -19th coulombs. And that's pretty easy to finish. So I used my calculator. I put in 2,000 times -1.6 EE, scientific notation, right? Times 10 to the -19th. And I got an answer of a Q final is equal to -3.2 times 10 to the -16th power, and that's coulombs. That's a very small amount of charge, but that's because 2,000 electrons is pretty small. Okay, so that's a very easy level 1 problem, because what's simple about it is that it starts off with 0 initial charge, and the number of electrons is a big number, but it's a whole number, 2,000. And I think those are a little bit easier. But then, if you were here in class, we tried some harder ones. Let's find and try one that looks like number 5. Okay, let's focus on 5. So the formula that we're generally going to use is Q final equals Q initial, and then we're going to ask ourselves, is it plus or minus N times E. So let's read the problem once and see if we can figure out. So we've got a metal charged sphere, some kind of object that looks like this, and it has a charge, so there's my Q initial, and it gains, and in this case, it's not really bold, but we can see gains, so we know that it must be plus. So let's start plugging in. The Q initial is negative 3.5 times 10 to the negative 6th coulombs. And then it gains plus how many? 3 times 10 to the 13th electrons, but each electron is negative 1.6 times 10 to the negative 19th coulombs. Okay, that's kind of the setup. It looks a little bit longer or bigger, and I've had different people tell me different tricks. Some people say they want to do this part first, and then add it to the number in the front. And that works very well on calculators. Or you can start at the beginning. Negative 3.5 times 10 to the negative 6th power plus parentheses 3 times 10 to the 13th. Remember second function EE on most calculators. Times negative 1.6 times 10 to the negative 19th. And on my calculator, I get negative 8.3 times 10 to the negative 6th coulombs. So that's a typical problem that we did right before our February vacation. The assignment today is to try the evens on page 21. So 8, 10, 12, 14. So are they all the same? Well, they're a little bit different. Number 8 is more like number 1 on the previous page. It starts off with an initial charge of 0 coulombs. N is 2500. And the elementary charge is negative 1.6 times 10 to the negative 19th coulombs. So you'll set up your formula. And it says it's gaining. So why don't we change even over to red? We'll just show that we know it's gaining. Back to blue, N times E. So that's a typical setup for number 8, and I bet you can work on that from there using your calculator. Number 10 is a little bit different, and we did do these before the vacation, but things have been split up. So this problem is not a gain or loss. This just has a charge on it. It's a Q with no gain or loss. The question is, how many particles does it have? Does it have more electrons and more protons? And the first step you ask yourself is it more electrons or more protons? And you notice right here that there's a negative sign in front of that charge. Negative charge means it has more electrons. How many? Well, really, we're calculating N. And we haven't done a practice one, at least not during this video, where what we're actually calculating is a delta Q, and we're using the part of the formula that's just the N and the E, not the Q initial, not the Q final part. So if you look back on page 20, you'll notice there's a separate equation. Okay, so the question is, how many extra electrons do we have? So negative 4 times 10 to the negative 6th equals N times, and the elementary charge is still negative 1.6 times 10 to the negative 19th coulombs. And now we just have to divide both sides by negative 1.6 times 10 to the negative 9th. So try it on your calculator. Negative 4, EE negative 6, divided by negative 1.6, EE negative 19th power. And I get an N of 2.5 times 10 to the 13th. And you might say, well, what's the unit on that? What is N measure? It's just the number. So you would just say it's 2.5 times 10 to the 13th electrons. And you're going to try the rest of the assignment. You can use the beginning of this video if you need to rewatch and see if you can finish all of it. Good luck.